Welcome to the 10th lecture in the open online course Computer Numerical Control of Machine Tools and Processes. So, in this lecture, after having finished 9 of the initial lectures, we will have some discussions, multiple choice questions and numerical problems on the last 4 lectures. We have already completed several numerical problems in these 4 lectures, and therefore, multiple choice questions which have not been discussed to that extent in the previous lectures. We will pay special attention to those in this particular lecture. So, let us go right ahead. Question number 1. So, what is the purpose of using recirculating ball screw nut mechanism in CNC machine? To reduce the setup time, for higher surface finish, for carrying out up milling and to remove backlash. To reduce the setup time, perhaps this is not very obvious, isn't it? So, there is no real correlation between reduction of setup time and using recirculating ball screw. So, first option no, that means option A no, for higher surface finish no, for carrying out up milling. Now, up milling and down milling are 2 processes in which the direction of rotation of the cutter and the direction of feed of the cutter, they are different. I mean, the combination is different. It is in down milling that it has to be ensured that the machine feed screws should be completely free of backlash. So, if we are talking about up milling, the question of having recirculating ball screw mechanism to ensure that up milling can be carried out is not correct. So, to carry out up milling is not the correct option. Last option is to remove backlash, and this is correct. So, option D, to remove backlash, is correct. MCQ 2. The following surface can be machined on. So, what is the surface like? The surface is uneven, smooth, but the surface is having undulations and they are irregular undulations, and this sort of a surface is referred to as a freeform surface. Do we have the application of such surfaces in engineering practice? Yes, we might have a car body which is not a regular surface. It can be different in different cases. It may be smooth, but it may not have regular geometrical or what do you call it, regular mathematically defined features on it. It might be having irregularities, or a die surface. So, it can be machined on a CNC milling machine, a CNC lathe, a conventional lathe, and a CNC turning center. Among these machines, the last 3, that means B, CNC lathe, conventional lathe, and CNC turning center, these are all generally producing surfaces of revolution, and therefore, they cannot produce such an irregularly shaped surface. So, the correct option is CNC milling machine. The main advantage of computer numerical control over conventional automatic control, which is referred to sometimes as fixed automation, is, so the advantage of CNC over fixed automation is being asked for. First option is CNC stylish, while automatic conventional control is not. And then B is CNC allows for application of higher cutting speeds and feeds. C, CNC is applicable in unmanned satellites. CNC offers higher flexibility than conventional automatic control, in brackets, fixed automation. So, first of all comes the question, what do we consider as advantage? We consider as advantage some feature of CNC machine which is desirable in certain machining situations and which is not present with fixed automation. So, let us see, CNC is stylish. Okay, CNC might be more stylish in some way, some people might be finding it more glamorous and stylish than conventional control, but it will in no way matter when, say, product quality is being considered. So, the first option is definitely not correct. CNC allows for application of higher cutting speeds and feeds. However, higher cutting speeds and feeds can only be achieved if there is certain improvements in cutting tool materials and in certain combinations of cutting tool materials and workpiece materials, which will permit the adoption of such speeds and feeds. CNC has very nothing to do with those combinations. So, this is also not correct. So, we have dropped two options. The third is CNC is applicable in unmanned satellites. Okay. Maybe yes, CNC is applicable in unmanned satellites and it is better than fixed automation, but there are 2 points to be considered here. Is this the main advantage of CNC over fixed automation? No, because we might not at all be concerned with unmanned satellites, but still we would consider CNC to be having some advantage over fixed automation. So, it is definitely, even if there be some advantage, it is definitely not the main one. Secondly, CNC is applicable in unmanned satellites, but fixed automation might be equally applicable in unmanned satellites. So, this statement to start with might not be correct, it might be misleading, wrong. So, third option is also dropped. CNC offers higher flexibility than conventional automatic control. Yes, this can be considered as the main advantage, because in situations where we have low volume of production, there this is the main advantage of computer control over fixed automation. So, the option D is correct. By the way, it is considered to be an advantage in the previous case. Let us go back. It is considered to be an advantage because since the since a specific part is being made in a small lot or batch, say 50 pieces, and after that you have a different part design being selected and machined. So, it is easy to change over from part 1 to part 2 in case of CNC, because we need only change few lines in the programs or just select a different program itself. So, changeover difficulties in changeover from one part design to another is much less in case of CNC. In a CNC machining center, any complex cutting motion involving X, Y and Z movements is carried out by. So, that means we are talking about a CNC machining center now, which we have learnt about in classification. Any cutting motion involving X, Y and Z axis movements is carried out by use of jigs, cams, templates and tracers. B, skill of the machine operator. C, combination of movements obtained from motors along the axis. D, none of the others. E, using specific gearbox settings that distribute power to the axis. So, first one, use of jigs, cams, templates and tracers, it is being some physical devices are being referred to, and these physical devices are not actually present in CNC machining centers, or for that matter in any CNC machine. So, first is not correct. Skill of the machine operator, definitely not, because human intervention is the least in CNC machines. They are basically automatic machines. Now, combination of movements obtained from motors along the axis. Yes, this is a good candidate, but let us check out the other options as well. None of the others. And last of all, using specific gearbox settings that distribute power to the axis. So, this means that if I am having a motor, from that motor I am deriving power, and through a gearbox maybe I am giving a particular RPM to x, that RPM multiplied by 2 to y, and that RPM multiplied by 3 to z. So, that means specific discrete combinations of rotations per minute may be available in the different axes, but that is it, nothing beyond that. If you want another ratio to exist between the axis velocities, you might go for a different gear combination gear setting, might be going for a different gear setting, but that is it. You have discrete options before you. If you want to go for something in between, or if you want to change that gear setting while during a cut, you do not have those options through option E. So, that is definitely not the case with CNC machines. So, this is also not correct. Therefore, so only C seems to fit the bill. So, combination of movements obtained from motors along the axis. The motors rotate, produce a particular speed ratio of speeds along axis, and that defines the motion which takes place ultimately in space. Sorry. So, a machine will be said to have CNC control if the dimensions of the workpiece are measured by sensors while cutting is going on. What does it actually mean? It means that some kind of online monitoring is taking place of the part quality. So, now is this CNC really? No, it is basically online monitoring. That part of the measuring what do you call it, measuring exercise might be CNC, but the machine is in no way CNC if this is being carried out. So, second option is the tool motion is guided by drum cams and disc cams. So, it is suggesting that some physical devices are guiding the tool. So, no, this is not CNC. Cams are physical devices which can guide the tool through its motion cycle. Then comes the loading and unloading of the workpiece on and off the machine respectively is made automatic. Now, a machine might well be CNC even though loading and unloading of the job might be manual. It's generally those machines are referred to as semi-automatic machines, and therefore, the actual machine movements have not been explained in C, and they have not been made clear, and therefore, only the aspect of loading and unloading becoming automatic does not render the machine CNC. So, not even C. Last of all, D, control is achieved by employment of alphanumeric data. This fits the bill, because alphanumeric data in the definition of CNC you will find in some way we are removing physical devices and bringing in instructions in the form of codes or letters or numbers or signals. Okay. Some sort of basic language communication has been talked of instead of physical devices. You can tell a person that I do not like you, or you can hit him on the head with a club. I do not like you stands for CNC, while hitting him stands for communication of information through physical devices. In computer controlled machine tools terminology, a machining center is option 1, the origin of the machine coordinate system with respect to which the operator has to make his program. So, this refers to the origin of the machine coordinate system. Absolutely not. Origin of the machine coordinate system is a particular physical quantity, XYZ coordinate value in the coordinate system. It has nothing to do with the machining center, which is a machine tool essentially. So, first option is incorrect. Then the center of the cutter, which actually goes to the programmed point when used without radius compensation. So, the center of the cutter, say the drill center, the milling cutter, if it is say an end mill, the center point of the milling cutter, axial point, no. This is also has nothing to do with the machine tool. Then a computer controlled machine tool capable of a variety of operations involving rotating cutters, that is it. This is the definition of the machining center. So, none of the others is not correct. Number 3 is correct. In computer controlled machine tools, tool movements are controlled by cam, machine operator, foolproof mechanism, none of the others. So, it is obvious, cam is a physical device, machine operator, human intervention, foolproof mechanism is a mechanism which is present in conventional manually operated lathes, and definitely it is not so. And so, none of the others is the correct answer here. Holes are to be drilled on the circumference of a circle with regular angular spacing. Remember that subroutine we had done. So, if a CNC machine is used, it should essentially have one indexing head mounted on the machine table in order to carry this out, and have a CNC rotary axis of motion to rotate the table about z axis. So, it is asking for a rotary axis in addition to XYZ motion in order to carry this out, and be a CNC milling machine with contouring control. Circular circumference of a circle has a number of holes. So, maybe it should be a milling machine. So, that circular interpolation is possible, and you can reach those points by circular interpolation and carry out those drilling operations in those respective places, and none of the others. Well, the first one is not correct. We have learnt in the program that instead of rotating the job physically, we are rotating the coordinate system physically. So, A is out. B, have a CNC rotary axis of motion to rotate the table, absolutely unnecessary. So, B is also out. We are doing everything virtually inside the memory. C, be a CNC milling machine with contouring control. Now, what is that? Why do we need to move by circular interpolation through those holes? We can just reach those holes as we know their coordinate positions. Circular motion as such is not necessary, and point to point machines are those machines in which once you reach the end point, everything is the path is not important. You need not necessarily move through those points in a circular manner. You just have to attain those positions. Okay. So, none of the others is the correct answer here. The following shape has to be cut on a milling machine. The raw material is flat metal plate 10 millimeters thick. In order to carry out CNC milling, we essentially require, what do we require? We require circular interpolation, we require straight line interpolation, all these things are required in 2 axes. Okay. The third axis need not have circular interpolation facilities. It can have linear interpolation, so that it can linearly dig into the cut and start it. So, the options are a 3-axis CNC milling machine with a copy milling attachment. No, we are not going to copy anything, because we are going to program for it. So, first is out. A is not the correct answer. Then comes a 3-axis CNC milling machine with a ball end milling cutter. Now, what are we going to do with a ball ended milling cutter? Ball ended milling cutters are generally used for freeform surfaces. So, this is also out. Next is a 5-axis CNC machine with a copy milling attachment, out. 5 axis, as we discussed, only 2 axis continuous control with the 3rd axis linear, that is enough. A 5 axis, so the correct answer is none of the above. Now, you are finding in many of these MCQs I am putting none of the above. Why is it so? It really tests out your confidence. A CNC milling machine tool has a continuous path control, both linear and circular, along x, y, z axis, and control of table rotations about x axis and z axis. So, we are talking about both linear and circular interpolation possible for x, y, and z, and control of table rotations about x axis and about z axis. So, the machine should be called first 2CL. Why 2CL? Because obviously, we are first talking of 3C and then 2 other axes as well. So, from that judgment A is out. Then we are saying 3L comma 2C, but why 3L? It specifically mentioned that x, y, z they are supposed to have continuous path control, both linear and circular. So, B is out. C, 5C, 5C seems to be possible because x, y, z they are contributing to 3C. Together with that, circular axis of rotation, that means rotation about x and about y, if they are possible, okay, then we consider them to be individual C or continuous axis. So, 5C is possible, I mean correct, and none of the others no. Of course, here something is slightly ambiguous, that whether this table control of table rotation is done at a controlled rate or not, we have not mentioned it. So, this ambiguity is there, it should be mentioned in order to remove any doubt. So, considering that this table rotation is fully controllable extent wise and velocity wise, we will in that case we will say that 5C is correct. That means C is correct. Next, for milling a bilaterally symmetrical 2D profile on metal plate 10 millimeters thick. So, we have a bilaterally symmetrical part now. A CNC machine, milling machine would require the following accessory or attachment. Let us see. Copy milling attachment is out, it is a physical device. Dividing head is out, it is a physical device. Reversing table, that means you do one side and possibly you reverse it and do the other side. Achha. Okay, let us see. And rotary table, okay, you can perhaps rotate it and do the other part automatically, perhaps that way, and none of the above. So, it is written it would require, that means it essentially requires, otherwise it cannot do it. This is the meaning. Is it possible? That is, if I do not provide you with these pieces of equipment, does it mean that you cannot do the 2D profile which is bilaterally symmetrical? No. You can straight cut ask for mirror imaging, or you can simply do the other side painstakingly writing all the lines of program. So, both are possible. So, that way this is having the answer none of the above. In order to produce a circular groove in milling in CNC machining center, I want to cut a circular groove. So, I require a universal dividing head. No, I do not. A planetary gear mechanism. which actuates the table movement? No, I really don't do that, I don't need it. A rotary table? No. Why? Because I can simply use circular interpolation and none of these things will be required. So, it means that when you are asking for rotary motion, I mean circular groove, the basic idea is the CNC machine table does not have to rotate. It can simply combine x and y motion, so that it will be undergoing rotary or rather circular motion. It does not have to rotate about a particular axis. No, not at all. This is the basic idea of this question. Rotary devices are not necessary. And planetary gears are going to give specific results, discrete options, so they are also out. So, answer is none of the above. CNC is not applicable in drilling machine, milling machine, lathe, all of the above, none of the above. So, CNC is not applicable. CNC is applicable in every one of them. So, the answer is none of the above. CNC machine tool has the following advantage over conventionally controlled machine tools. Let us see. Surface finish of machine part is higher. No. Surface finish depends upon something else. It depends upon tool geometry, it depends upon the feed applied, etc. So, it has nothing to do with CNC. Cutting forces are less? No. Cutting temperature is lower? No. None of the above is the correct answer. The incremental encoder is capable of sensing. So, incremental encoder, remember, capable of sensing direction of movement of the table? No. Direction of rotation of the lead screw? No. Direction of rotation of the motor? No. None of the above. In a point-to-point feed axis employing a stepper motor as a prime mover. So, point-to-point machine, stepper motor, an encoder for position feedback is a must. No, because stepper motors can well operate in open loop in a point-to-point system. An interpolator is a must? No, interpolator is not required in point-to-point machines. A Tacho generator is a must? No. None of the others is the correct answer. A XOR B is equal to A and B or A dash and B dash, A dash and B or A and B, A dash and B or B dash and A. C is the correct answer. That means option 3 is the correct answer. You can check it out through truth tables. A CNC machine, milling machine would have point-to-point loop control only. No, CNC milling machine is capable of circular interpolation, straight line interpolation. So, option A is not correct. Point-to-point closed loop control only? No, for the same reason. Contouring control? Yes. None of the above? No. So, option C. The function of the Tacho generator is reduction of basic length unit? No. Faster response of the motor? Yes. To make 3D interpolation possible? No. None of the above? No. So, the correct answer is faster response of the motor. CNC machines find widest application in the field of mass production? No. Small lot and batch production? Yes. Non-conventional machining like ultrasonic machining, laser beam machining, then electrical discharge machining, etc. Well, CNC might be applied, but it is definitely not its widest application application field. Okay. So, small lot and batch production is its actual field of application. CNC machining has the following main advantage over conventional machining practice. The ability to employ higher cutting speeds? No. flexibility. Flexibility is the answer, and C is feedback control. Feedback control is not an advantage. Feedback control is actually a means to ensure that proper quality will be maintained and proper movements will be carried out. So, it is not an advantage, but it is one of the supporting foundations to ensure proper working. So, on the CNC lathe, 2-dimensional programming is sufficient, 3-dimensional programming is necessary, 1-dimensional programming is sufficient. Here the correct answer is A, because we only have motion along the axis of rotation and we have motion radial to the axis of rotation. 2 axes of motion, they are necessary on the CNC lathe. Interpolator is present in case of point-to-point open loop system, no. Point-to-point closed loop system, no. Contouring control system, C is the correct answer. In a CNC turning center, threads of different pitches are cut by different settings of the meander, drive and Norton tumbler gears, no, they do not exist in this machine. Different settings of the feed gearbox, no. Different settings of the speed gearbox, no. None of the others. A point-to-point control CNC machine does not have an interpolator, that is correct. Does not have a position down counter, that is not true. Position down counter is present in all CNC machines. Never has DC motor as prime mover along any feed axis, that is not correct. You can well have DC motors with closed loop, none of the others. So, the correct answer is does not have an interpolator. CNC machines find the widest application, this we have already done. The correct answer will be small lot and batch production. In a CNC milling machine, a circular cut is always produced. We have done something similar to this. By operator's skill and experience, no. By copy milling, no. By combined motion of feed axis, yes. C is the correct answer. A XOR B, I am not solving it. I am sure the amount of Boolean algebra practice that you have had, I am sure that you can carry this out. In case of a CNC drilling machine, whenever there is a table motion, the speed of XY table along X axis is always same. Always same? No, it can be 0. It can be the maximum speed possible, or it can be 0. See, it is not always same. Can be different for different lines of program. Yes, it can be different. It can be 0 or it can be the maximum speed. So, it can be technically different. Is always 0? No, in that case we would not have had that axis of motion at all. None of the others. So, strictly speaking, B fits the bill. In all motions, X motion might not always be present. So, it can be 0 at times, it can be the maximum speed of the motor at times. Okay. So, with this we come to the end of the 8th lecture. There are some other MCQs also which I did not discuss just now because of dearth of time, but I will definitely share it with you in other sessions of lectures that are going to come. Thank you very much.